I'll discuss about the variation of acceleration due to gravity with depth. Suppose our aim is to find out the value of acceleration due to gravity at a depth d below the Earth's surface. So we can consider that Earth as a solid sphere, and same as like we discussed the gravitational field inside a solid sphere. So we'll calculate the value of gravitational field inside a solid sphere by using the equation gmx divided by r cube. Here also we can use the same technique. Over here the value of x is nothing but distance from the center. So if we are considering a depth d below the Earth's surface, so if you are measuring the distance from the center of Earth, that will be r minus d. So instead of x we can take it as r minus d. So acceleration due to gravity g we can take it as gm into, instead of x we can go for r minus d divided by the radius of Earth, we can take it as r cube. So g is equal to, if you like to write this one in terms of g naught, that is acceleration due to gravity on the surface of Earth. So we can write as gm divided by r square into r minus d divided by r. So you can write this g at a depth d is equal to nothing but gm by r square is acceleration due to gravity on the surface, into r by r we can take as 1 minus d divided by r. So we can use this equation for the calculation of acceleration due to gravity inside the Earth or at a depth d below the Earth's surface. Now if we are taking the value of this d is equal to r, d is equal to r means it is at the center, then according to the equation acceleration due to this gravity at the center becomes equal to 0. So we can say that as the depth increases, acceleration due to gravity decreases, and we can find out the decrease in value of g at a depth d, that is decrease or change in value, is equal to nothing but actual value minus at a depth acceleration due to gravity at a depth d. So we can take it as it is g naught minus g naught into 1 minus d divided by r. So you can write the value of this change in acceleration due to gravity is actual acceleration due to gravity into, or acceleration due to gravity on the surface into d divided by r. Or sometimes they will ask to find out the fractional change. So we can write this fractional change is change in value with respect to its original value. So we can write that is equal to d divided by r. So as we discussed the fractional change with respect to height also, there we write that this fractional change is equal to 2h divided by r for small values of h, and with respect to depth the fractional change is d divided by r. So with respect to height is 2h by r, so we can say that decrease in g at small height is more than decrease in g at small depth. Means if you are changing by same distance, let us small distance x above the Earth's surface, or if you are going below the Earth's surface, so that change will be more if you are moving above the Earth's surface. Decrease in value of g will be g at small height is more than decrease in g at small depth. But we know that the value of g at a height h, if the value of h is not less than that of r, then we'll use that equation, which is g naught divided by 1 plus h divided by r the whole square. And acceleration due to gravity at a depth d, if this same equation we'll use irrespective of the value of d is much greater than that of r, or if it is comparable with respect to r, and the equation was g is equal to g naught into 1 minus d divided by r. So according to this equation we can say that decrease in g at large height is less than decrease in g at large depth. Already observe that g becomes 0 at center of earth. It's like variation of gravitational field. Over here we can represent the variation of acceleration due to gravity with respect to distance from the center. So the center acceleration due to gravity is 0, and with respect to distance from the center it is directly proportional to x, and at the surface this is having a maximum value which is equal to gm divided by r square, then it is inversely proportional to x square, and at infinity it is going to be 0. So from the center to surface, g is directly proportional to x distance, and it is, after it is moving outside the earth surface, it is inversely proportional to square of distance. This one shows the variation of acceleration due to gravity with respect to distance x from the center of earth.